All right, so in theory, before we get to this, we should already know how to do like basic factoring. So like if you've got, I don't know, x squared plus 6, no, 5x, that's a classic. X squared plus 5x plus 6 is kind of a classic. And I say, factor this, and you go, okay, so I'm going to reverse FOIL it and do something like this. And both signs are a plus, so I plus, plus. And then I think about, well, what factors of 6 can I add up together to get 5? And theoretically, if you've been doing this long enough, you say it's 2 and 3. And because we always do, we put an x here. That's a terrible explanation, but that's kind of, if you try to think through the whole thing every single time you do it, it's going to take too long. So you just kind of get into a pattern, like a flow of it, and it just works so well. So that's that factor. You can do other things that look harder that really aren't. So like this. Now that looks like ridiculous, right? But it's not. Because the first thing you can do is you can say, well, I'm going to factor out a 3. So if I pull a 3 out, then what I have left, if I pull out a 3 out of the first term, I've got x squared. If I pull a 3 out of the second term, I've got a 5 left. And if I pull a 3 out of the last term, I've got a 6 left. So that's really 3 times this thing, which is the same thing we had over here. So that would just be, x plus 2 and x plus 3. So whenever you're looking at trinomials with extra stuff, you always have to make sure that it's not harder. Like I would say that this is like a 5-point problem, and this is like a 2-point problem. And they're really the same thing, you just have to recognize that there's a 3 out front. So that's fun. Now occasionally you can get stuff out front that doesn't factor as well. So for example, you could have a question that looked like 3x squared plus, or minus, make it minus because that's funner, minus 5x minus 2, and they say factor this. You can say, oh, I'm going to pull a 3 out. But if I do, well, then I'm really left with this, which actually isn't all that much more helpful. So let's not pull out a 3, because that just makes life worse. And in this case, and this is actually a review. If I'm going too fast, it's because I'm theoretically thinking that you've already been exposed to this at some level. This is just like a guess and check thing. I'm pretty sure the first part's going to look like this. One is going to be a plus, one's going to be a minus. I'm not sure which is which. If I mess with the factors, eventually I can say, oh, this goes like this, and so that's going to be that, and yay, I'm good. But things aren't always that easy, and for things like that, you just really got to play with it over and over again. So when you're thinking about trinomials with extra stuff, which is the title of this fabulous video, I'm going to look at all different kinds of ways of doing this. So let's see. So here's what I'll take it through. Actually, let's take this guy and save him for later. All right. So now let's look at this guy again and see what they could do to make this kind of ugly. I'm basically going to rewrite the same thing, just do it a little different. Is that helpful? X squared plus 5xy plus 6y squared. Okay, and this throws off a lot of people because they're like, what do I do with all these extra y's? I'm going to tell you a secret. Probably shouldn't say this out loud. I don't do these. I pretend they're not there, and then I put them in after the fact. And everyone I know who's like mathy gets really mad at me when I do that because they're like, that's not right. But that's what I do. Honestly, the way that I work these problems is if I see there's like an extra squared term at the end, and there's a non, so if it's like squared and unsquared, just like you have squared and unsquared, right? Squared, unsquared, squared, unsquared. So if I have squared and unsquared, I kind of like pretend that they're not there. Well, that was a horrible color to use. I kind of pretend they're not there. And then I just solve the problem that's remaining, which would be x squared plus 5x plus 6. So I already know that. And then I go, oh wait, there's a y, because it actually is there. And then I stick the y back in. And the appeal of this is that I don't have to think so hard, I guess. But let's just check and make sure that my really horrible method of doing things works. If I FOIL it, first, outer, inner, last, FOIL, yeah, okay. First, x squared, outer, inner, And then last, don't let it freak you out because this is 2y times x. It doesn't matter what order I write it in. So 2yx is the same thing as 2xy. So I'm just going to write it like that. There. Woot. And this is the same thing that I got before. And it's a horrible, horrible method, I suppose, pedagogically, but I've always found it really effective. So let's try and see how it looks on this other example that we did over here. Here we go. So let's move him out of the way again. He's just not having any luck today. And I'm going to write 3x squared plus 15xy plus 18y squared. And again, on a problem like this, the first thing I'm going to do is I'm going to pull that 3 out. Oops, but I should actually do it correctly. That would be awesome. And then what I'm going to do is I'm going to say, we've got a squared z's and an unsquared z, so I'm going to pretend those don't exist. Now, don't forget to put them back in later, because then you'll definitely get it wrong. This is like a 10-point problem. If I was writing a test, I can't really see it. But, come back. I keep erasing my y. Silly me. Anyway, I'll pretend that these aren't here for a sec. And I can say, oh, well, I can totally factor that because, you know, I'm awesome and stuff. So, x plus 3. But then I say, oh, don't forget I have a y. Because you can't forget that I have a y. And I just stick the y in there at the end. Because it's kind of like cheating, but it's okay. Because you get the right answer. And it's not really cheating. It's just making the problem easier to solve. Math is all about taking a problem you don't know how to solve and turning it into something that you do. And anyone who tells you differently is lying. It's all about pattern matching. So if you can match the pattern, dude, you're good to go. So let's look at this guy one more time. And I'm going to do the same thing. 3x squared minus 5xy minus 2y squared. Let's do something weird. Let's pretend the problem that actually looked like this. Don't let that throw you. They're just trying to mess with you. This is just like, ooh, we're going to try to trick them. Don't let it happen. The squares goes on the outsides. The unsquared z's goes in the middle. So if you end up with a problem that looks like the first line, rewrite it as the second line. So if you have something that looks like this, rewrite it like this, and you're good to go. So again, if I'm solving this problem, let me move him down so he's not so squished. If I'm solving this problem, the first thing mentally that I'm going to do, I'm not going to really scratch it on my paper, but I'm just doing it for funsies. I'm going to do mentally is I'm going to pretend those aren't there. Then I'm going to factor out what I have remaining. And then I say, oh, can't forget my y's, or whatever variable it is. 1 times y, 2 times y. So instead of writing 1 times y, I can just write y. And again, if you want to check the FOIL on it to make sure you get the same thing, first, outer, inner, last, and so it's 3x squared. You should always check everything anyway. Whenever you're doing your homework or tests or whatever, every time you factor something, you should multiply it back out again and make sure you get the same thing that you did. So really, it's not that weird. It's just a irritant that they do to mess with you. It's fun. It makes math people happy.